Given question, determine the force developed in the member DF of the truss. Length of each member is equal to 5 meters.
In this question, we have to find out force in the truss member DF. We are going to use section method. We have to create the section that it will pass through this member DF and it will separate the entire truss into two parts. So I will make here the section 1 with the help of dash line. Now it is passing through this member DF and it separates the entire truss into two parts. Now we are going to consider left hand side part. So we will show the direction of force is in the outward direction from this member D. And this force in the member DF, that is FDF, we have to find out. So we are not going to consider this right hand side part. So I will remove this part. We are going to use the virtual work method. We will consider this entire truss will rotate about this point E. Now if we observe this point E and this point D getting connected with vertical line. So when it is rotating about the point E, that is this member AE is getting rotated by a small amount delta theta. At the same time, this vertical member ED is also rotated through a small amount delta theta. So we will show the new position of this truss. So this member AE is rotated through an amount delta theta. And here is this member ED. It is also rotated through an amount delta theta. So here is delta theta and here is also delta theta. Now we will connect. Now here is the new position of this point A, that is A dash. This is the new position of B, that is B dash. Here is the original position D and here is the D dash. Now if we observe the number of points where the different forces acts, then at point A 50 kilonewton force act in downward direction and displacement of this point A is here from A to A dash. So we will say it is delta YA because it is in vertical direction. So I have used here Y. Then next is point B where 50 kilonewton force acts in downward direction. So here also displacement from B to B dash. So this displacement I will say delta YB. Now in the same way we have to find out force in the truss member DF, that is FDF. So this point is also having some force. So we will find its a displacement from D to D dash. So it is in the horizontal direction. So I will say that it is delta XD. How to find out the vertical distance A to A dash? So we will consider the triangle A dash E. Now if we observe this triangle, then suppose here is the angle theta, then I can write here sin theta is equal to A dash divided by AE. But this theta is very small, therefore sin theta is equal to theta, and this theta is nothing but it is equal to delta theta. So I can write here delta theta is equal to A dash divided by AE. So each side of the member is given 5 meter, that is AC plus CE, that is 5 plus 5 10. So A dash is equal to 10 delta theta. So I will write here delta YA is 10 delta theta. Now we will move to the next, that is YB, that is B dash. Now if we observe here, then we will consider the triangle B dash D dash. So here also there is the small angular displacement delta theta. So in this triangle B dash d dash, we can write here b dash is equal to this length of the member BD dash, that is phi into delta theta. So I will write delta by B is equal to phi into delta theta. Because we know that this D to D dash is horizontal line and this is the inclined line. So here also same angular displacement is delta theta. Now we will move to the next. Now we have to find out delta xd. So this displacement. So for that we will consider the triangle D dash E. So in this triangle here is the delta theta. And what is the length of the member ED? That is phi. So delta xd is equal to phi delta theta. Phi delta theta. Now we will resolve this FDF into two components, horizontal component and vertical component. So I will resolve here. Now if we observe, this angle of inclination is 45 degree with horizontal. So here with horizontal component angle is 45 degree. So how we can say this? FDF cos of 45. And here FDF sine of 45. Now the displacement of this D to D dash is along horizontal direction. So displacement along this vertical component is 0. So I will write here FDF sine 45, displacement is equal to 0. So we are going to consider only horizontal component. So when we apply virtual work method, then we have to take force multiplied by displacement. So at point A, force is 50 kilonewton, but it is in downward direction. So for downward direction, we will use negative sign. For upward direction, we will use positive sign. For horizontal forces, for direction towards right hand side, we will use positive sign. Direction towards left hand side, we will use negative sign. Now we will take minus 50 multiplied by displacement. So this displacement is in the upward direction. So we will use positive sign, that is 10 into delta theta. Then next we will take here minus 50. Displacement is in the upward direction. So we will take positive sign, that is plus phi delta theta. So minus 50 multiplied by phi delta theta. Now again we are going to use this component only, FDF cos 45. So direction is towards right hand side. So we will use plus sign. So plus FDF cos 45 multiplied by displacement. So displacement D to D dash is towards the right hand side. So again with positive sign we will use phi into delta theta, which is equal to 0. Now we will take delta theta as a common term and we will transfer to the right hand side. So it will become 0. So 50 into 10, that is minus 500, minus 50 into 5, that is 250, plus FD cos 45 into phi delta theta. So cos 45 into phi is 3.53 is equal to 0. So FDF is equal to 212.4 kilonewton.